T-3 to episode 100. Hello and welcome. This is Michael Annis, and you're listening to episode 97 of the Space Rocket History Podcast. And now, Soyuz Test Flight Number 2. Recapping from episode 96, the first Soviet test flight was a catastrophic failure. Due to negligence, the attitude control system malfunctioned and used all of its fuel before a rendezvous could be attempted or even the second Soyuz rocket could be launched. When the Soviets attempted to return the first Soyuz to Earth, the vehicle's self-destruct system activated because it was unable to make a landing in the Soviet Union. OKB-1 was disgraced. After things cooled off a bit, Bashuyev and Vyacheslav made a proposal to speed up the launch of the passive Soyuz vehicle for a solo mission to thoroughly check out all the systems and to get the next pair of Soyuzes, 3 and 4, ready for a rendezvous and docking mission. After consultations with the launch team leader, Kirillov, and others who would be involved in launching at the Cosmodrome, a December 14, 1966 launch date was set for a solo version of the Soyuz 7K OK. Lest we forget, the Soviets are still committed to a circumlunar flight. Chief Designer Mission held a meeting of the Council of Chiefs during which they examined the amended Soyuz flight development tests and the draft schedule for the manufacture of the Soyuz 7K L1 vehicle for a lunar flyby. The first piloted circumlunar flight was supposed to take place in June of 1967. Before this, in the first half of the year, 2 space vehicles were supposed to perform a circumlunar flight without returning to Earth, followed by 2 that would return to Earth. The piloted circumlunar flight using Shalomi's new UR-500K carrier rocket and OKB-1's 7K L1 spacecraft was just 6 months away, and the Soviets were not even ready for the first unpiloted launch. Moreover, in addition to the 2 vehicles already shipped to the Cosmodrome, 3 remained that had yet to be fitted out with dozens of instruments, and for this reason could not even undergo factory checkout test. The primary 5th piloted vehicle was completely empty. Everyone agreed the date was unattainable, but no one was willing to inform Moscow. Okay, back to Soyuz test flight number 2. At the State Commission meeting, Chairman Karimov insisted that to avoid redundancy and confusion, the main operations control group would be the same as for the first test flight, which included Agazanov, the flight director, Ryazansky, the radio guidance specialist, Vyacheslav, Roshenbach, and Chertok. The control group would have to be at Tracking Station 16 in Yevpatoria within 24 hours for a readiness check and then report to the State Commission before its last pre-launch session. During launch preparations at the Cosmodrome, Gregory Levin was assigned the role of communications officer with main operations control group. Mission, Kirimov, and Kamanin and the future Soyuz crews were to fly to Yevpatoria from the Cosmodrome immediately after the launch. On the morning of December 13th, just 1 day before launch, Chertok, Ryazansky, Roshenbach, Vyacheslav, and a dozen or so members of various groups flew to the Crimean Naval Air Station in Saki and met up with Agazanov and Deputy Chief Designer Tregrub to have lunch in the dining hall. As they ate, they discussed their dissatisfaction with the control center's state of preparation. The situation in the control center reminded Chertok of a stirred-up anthill. Previously, during the first Soyuz test flight, organizational factors had led to many mistakes. Group T, with the authority of Chief Designer Mission, had to eventually take control of that flight. The control center also had a logistics problem because the communications facilities and all the groups needed for operation control were located at the tracking station number 16, which was several kilometers away. Also, during the first Soyuz flight, many flaws were discovered in the ground control complex. So, for this second test flight, Agazanov and Tregrub organized individual and general training sessions simulating the flight mode in order to achieve a mutual understanding between the military personnel who listened to their commanders and industry specialists who believed that the military commanders only interfered with work. With less than 1 day before the launch, Ryazanski and Chertok called a meeting, during which each specialist, regardless of military rank or departmental affiliation, could lay out his or her complaints and recommendations for putting things in order. The attendees of the meeting included the control group, the ballistics group, the analysis group, and Colonel Rodin's telemetry group. The first complaint came from Control Group Chief Colonel Ryab-Atayagov. He was the last link in a long decision-making chain. One of the duties of his service was to transmit the contents of commands to all tracking stations on Soviet territory and to the ships on the Seven Seas. Within at least 20 minutes, each ground and sea station had to receive the exact time that coverage would begin, target destinations for antenna setup, the sequence and codes of the commands transmitted on board, and a list of the top priority telemetry parameters that needed to be processed. In turn, his service had to keep track of the receipt of confirmations from the stations that directives had been properly executed and to give new instructions. At the meeting, Colonel Rabatayagov complained that there was no order during a session. When there should have been silence and everyone should have been busy, there was hectic running around from room to room for information, a result of responsible and irresponsible specialists searching for each other in order to be the first to report their ideas to management. The colonel also said that communications throughout the country on the whole could not cope with the telemetry traffic that needed to be transmitted to Yevpatoria. After extracting the essentials, this traffic needed to be reduced. This was obvious from the first test flight. Colonel Rodin, who led the telemetry group, proposed using the Monia satellite for communications, a good idea. The telemetry service was one of those in which the military and civilian specialists worked in complete harmony. They had already started a tradition of resolving their internal conflicts on their own rather than airing their dirty laundry. The analysis group caught most of the grief. This group included about 24 leading specialists, each responsible for his or her onboard system. Each demanded that the parameters that they were interested in be processed first, and each hurried to be the first to report to the supervisor that everything was okay or there was a problem. Obviously, this behavior had to be corrected. Additionally, the information transmitted from the stations via telephone depended upon what military officer was on the phone at the time and what he deemed was important enough. The ballistics group admitted that they were late giving out the coverage zones. The problem was the ballistics calculations still hadn't been set up in the local computer. Currently, everything went back through tracking station number 4 in Bolshevo. But The ballistics group was prepared to provide real-time computation here on site for the upcoming launch. Summing up the meeting, Flight Director Agazanov and Chertok mainly gave out do's and don'ts. Don't shout during communication sessions. So-and-so should sit over there. Communicate only this type of information by telephone, etc. In the remainder of the meeting, it became clear that in order to control two vehicles simultaneously, a division needed to be established in the groups for active and passive vehicles. On the morning of December 14th, Group T reported to the State Commission that all flight control services were ready for launch of the Soyuz Test Flight 2. Everyone that was supposed to gathered in the large room that was called the Central Control Room. Agazanov, Tregub, and Chertok formed a group that would take over control of the Soyuz immediately after it separated from the launch vehicle. They sat shoulder to shoulder around a single table covered with dozens of telephones, among which a microphone stood out in front of number 12. That was Agazanov's special call sign. A stand in front of them held placards with call signs, command designations, and a color-coded program of the first 24 hours of flight. At that time, they still did not have any screens or electronic monitors displaying information. They received 90% of all information by ear. Behind Chertok's control group were the main representatives of the large analysis group. They too were supposed to receive all telemetry reports by ear and ballistic prognosis data over the public address system. They were also responsible for monitoring the control group's conversation with the tracking stations, receiving reports about the execution of commands, rapidly grasping what was going on, and giving the control group advice as quietly as possible. There were several dozen specialists for all the systems. They were located in other rooms. If an individual responsible for one system or another was in the control room and wanted to consult with his subordinates, he darted out of the main hall and ran to look for the people he needed. If he didn't get a clear answer, he usually brought back several people with him, and then a raucous discussion started, interfering with the hearing of the operational information. Reprimands were of little help, and there was the danger that if they experienced several off-nominal situations on board, there might be chaos and unpredictable consequences on the ground, which was mentioned at the meeting the day before. But on December 14th, after announcing their complete readiness to the State Commission, at T-4 hours, after having calmly eaten lunch, everyone was sent to their stations. The launch was scheduled for 1400 hours Moscow time. After receiving the announcement of T-5 minutes from the Cosmodrome, the public address system and everyone else in the room demanded total silence. Then, the T-1 minute announcement. The announcement passed through all the ground and ship-based tracking stations. Dozens of encouraging reports of T-1 accepted were received via the ground voice communication system, from Moscow and Yevpatoria all the way out to Kamchatka. At dozens of tracking stations, hundreds of people in equipment rooms stood absolutely still. The ships, Chasma and Chemykin, awaited signals in the Pacific Ocean. In the Gulf of Guinea, the Dolensk was rocking about on stormy waves, and the telemetry operators were waiting for the first orbit. But T-60 seconds dragged out. Everything was silent. Sometimes no information is worse than bad news. Then, finally, 30 minutes later, Group T received the command from the State Commission. Switch off all equipment and systems. What had gone wrong? Here's what happened back at the Cosmodrome. The pre-launch test, the fueling of the tanks, and all the final operations ran their course without a glitch. The pre-launch State Commission meeting went smoothly. All the chiefs once more concluded that there were no glitches and there was complete readiness. At T-minus 15 minutes, in keeping with tradition, a group left the launch site and went down into the bunker. They included Kirilov, Mishin, Kozlov, and his deputy for testing, Mikhail Shum. The vehicle testers were at the consoles of the launch station. Kirilov and Sabarov were standing at the periscopes. Site number 31 now had combat status. The vehicle's consoles were manned by disciplined, knowledgeable officers from the combat missile crew. At T-minus 60 seconds, Kirilov began to monitor the rocket through the periscope. He dictated the traditional set of commands. Feed 1, which meant to start recording telemetry data. Key in launch position. Vent. Feed 2. Launch. After that, the automatic control system was supposed to work according to the timeline for the ignition of all the engines. One after another, the flickering display lights on the console indicated that operations had been performed and the ignition squibs in all the engine chambers had fired, except for one on a strap-on booster. It turned out that the igniter of one of the chambers was not ready for ignition, and the automatic equipment tripped the circuit. It would be possible to reset and make another attempt at ignition after inspecting all the chambers, replacing the igniters, and determining and correcting the cause of the failure. Usually in such situations, the fire commander accepts responsibility. If Kirilov had been here, Kirilov would have asked for his consent. Now, Kirilov took the entire responsibility on himself. The launch crew was ordered to go up to the rocket, inspect the engines, and find the cause of the failure. The missile service platform was extended out toward the rocket, providing access to the engine nozzle. Kirilov, Chief Designer Mishin, and Kirimov climbed out of the bunker to the zero marker. From a clear sky, hanging low over the horizon, the winter sun provided good illumination of everything happening at the launch site. Suddenly, somewhere above the rocket, there was a blinding flash of light accompanied by a violent popping sound. The engines of the emergency rescue system, the NASA equivalent of the escape tower, mounted on the exterior of the fairing, had fired up. The crew on the launch pad watched in amazement as the solid propellant engines of the emergency rescue system carefully carried the descent module away to an altitude of 700 meters and deployed the parachute. It landed a half-kilometer from the launch site over the hill. The nose fairing halves crashed down next to the launch pad. Kirilov managed to turn his attention in time to see the sparks that were dancing above the ruined top of the carrier rocket. It was not difficult to imagine what might happen after the fiery plumes that had been flowing down. Kirilov gave sharp commands over the public address system. Everyone clear the launch pad and go immediately to the bunker. Leave the service platform and go to the back gate toward the underground oxygen factory. We need water on the launch site. Everyone fled as fast as physically possible. Then the pipelines of the liquid thermal control system ruptured. The coolant fluid contained in the pipeline was more combustible than gasoline. It caught fire from the flame of the emergency rescue engines. With the descent module gone, the peroxide system from the vehicle's instrument compartment, which had been left on the rocket, lost its pressure integrity, and the fire spread to the rocket's main boosters, which was soon accompanied by explosions that showered buildings standing 1 kilometer from the launch site with glass and plaster. The process developed in such a way that by the time of the most violent explosion, which destroyed the launch facility structure, people had managed to take cover in the bunker or in the fortified gate. However, one officer perished. He took cover near the rocket behind a concrete structure, which withstood the explosion, but he was killed from smoke inhalation. With the launch site still burning and the fire suppression systems unable to cope with the fire, the investigation of what went wrong started. The obvious cause of the fire was the activation of the emergency rescue engines, but why did that system activate? Electrical engineers in the bunker were frantically thumbing through thick albums of electrical diagrams and refreshing their memories on the escape system's operating logic. But the answer proved to be unbelievably vexing in terms of its simplicity. The command gyroscopes of the rocket's central core booster had been provided with emergency contacts for the rocket's emergency destruct system and the emergency rescue engines. If the rocket's angular deviation during flight relative to the direction of the gyroscope's axes was at an angle many times greater than the design value, the contacts would close. But the rocket did not fly, it did not vacillate, and it did not deviate. So why did the emergency contacts of the gyroscope that had already been shut down after the circuit was tripped closed? After power was removed from the gyroscope rotors, they have a prolonged run-out period. It takes about 40 minutes for them to stop. All this time, their axes deviate relative to the fixed housing containing the emergency contacts, because the rocket spins along with the Earth. When the deviation reached the set point, it triggered the emergency escape system, whose solid propellant rocket engine started the fire, which led to the explosion. So, if the escape system activated, why didn't the self-destruct system activate as well? The reason was the self-destruct system was prevented from operating when the rocket was powered down, but the emergency escape system was not. No one had thought that while saving a cosmonaut, the escape system would be capable of setting on fire and destroying a perfectly good rocket that hadn't even failed. But, on the positive side, the emergency rescue system executed and the soft landing system activated as well. So if a living cosmonaut had been in the vehicle rather than a mannequin, he would have come to no harm after landing about a half a kilometer from the launch site. The launch pad at Site 31 was knocked out of action for an extended period of time. The State Commission, which convened at the Cosmodrome on December 16th, made the decision to immediately prepare Launch Site Number 1 for Soyuz launches. Since Soyuz Test Flight Number 2 was another catastrophic failure, the schedule had to change. They decided to launch the third Soyuz test flight on January 15, 1967, and a docking mission was scheduled for 2 Soyuz in the month of March. The first space decade and the first year of OKB-1's work without Korolev ended terribly. After 2 accidents in a row of the new Soyuz vehicles, people started to say that under Korolev, this would not have happened. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.